Hi, this is Irv Shapiro with the Make with Tech YouTube channel, formerly the Dr. Vax YouTube channel. And today I'm surrounded by printers. And the reason is we're going to talk about 3D printer speed, specifically a couple characteristics that impact speed. This is an Ender 3 version 2. It's stock, except for I've added a BL Touch sensor to it and upgraded the Marlin 2.0 firmware to support it. This is an Ender 5. Originally, this Ender 5 was extensively updated with a variety of components that we'll talk about in a couple moments. But most importantly now, I've recently updated it with a Micro Swiss Direct Extruder with an all-metal hot end. And we're going to look at which one of these printers is faster and which of the upgrades, which of the components influence that speed. So stay tuned and let's learn something together. Well, folks, I'm a lucky guy. As a reviewer on YouTube, I have a whole bunch of 3D printers. The majority of them, these two as an example, I paid for myself. Others, sometimes manufacturers, send to me in order to do a review, and sometimes components are added in order to do a review. Today, we're going to look at an upgrade to my Ender 5 from Micro Swiss that I paid for. I have no connection to Micro Swiss. And we're going to compare this Bowden style Ender 3 printer with this now direct drive Ender 5 printer. And we're going to look at the speed of printing a couple different types of prints, but one in particular. These prints are designed to hold a watch on your nightstand, on your bookcase. In my case, I have a variety of watches. This happens to be an Apple Watch, but I have a variety of watches from Citizen that are charged via light. And so I like to stick them in a window every once in a while so they get a lot of sunlight. Now, I'll tell you, if I was to look at these two prints, not knowing anything about this video, I couldn't tell the difference. But this one printed 40% faster than this one. And that's what we're going to discuss today. Let's start by looking at architecture. Of the 3D printers that I own, the fastest two that I've owned historically are my Prusa i3 MK3, which is the first 3D printer I ever purchased, and my Monoprice Ultimate 2. So what are the characteristics in common between those two very different printers? The first is they both are direct extruder printers, direct drive extruder printers. Could be the whole difference. We'll determine whether it is. The second is they both have very rigid frames. If we compare the frame on this Ender 3 to this Ender 5, the Ender 3 frame does the job. But because they're single vertical columns here, extrusions here, it could twist a little bit. It could vibrate a little bit. In the case of the Ender 5, it's a complete box. That's going to minimize any vibration of the frame. The other very interesting difference between these two printers is on the Ender 3, the print bed moves back and forth. So in order to print at a different Y location, remember we have X, Y, and Z. In order to print at a different Y location, you have to move the print bed. And you know what? You do that a really lot. So that print bed is vibrating a lot. That means that it puts vibrations on the frame. The frame starts to vibrate. That impacts quality. So what do you do to get great quality on a printer with this structure? You slow it down. Now let's look at the Ender 5 for a minute. The Ender 5, the print bed only moves up and down. Up and down. And when do you move the print bed up and down? When you switch layers. Now, you may also move it up and down slightly if you're using Z-hop a lot. But if you're not using Z-hop, then most of the movement is switching layers. So the number of moves required by this print bed are smaller than the number of moves here. This is shaking back and forth. This, if you watch it, is gently going up, maybe every once in a while going up and down a bit. So overall, the design of this printer would make it seem more stable. How does that compare to the Monoprice Ultimate 2 and the Prusa, which are my fastest printers? Well, the Prusa has a frame that has this single shape, but it's made of a different material. It also has dual Z-axes, so dual rods. It has multiple rods going along the X-axis, and so overall it's more rigid, quite a bit more rigid. So it has direct extruders. They both have direct extruders. They're both more rigid. Why is the Ultimate 2 more rigid? Well, it's a fully enclosed printer. It looks like a box, fully enclosed. The other thing that's different is both of those printers have auto bed leveling. Why would that impact speed? Well, we're not going to test it today, but I believe that I'm able to print faster on printers with auto bed leveling because I get a bit better bed adhesion. That's not to say you can't get great bed adhesion without auto bed leveling. You absolutely can. You just have to maybe fine-tune your bed leveling manually more often. With those characteristics in mind, let's focus on this Ender 5 for a minute. And you can see here on the slide, this is no longer a stock Ender 5. In fact, the only thing that's stock are the power supplies, the frames, the stepper motors. Everything else has really been changed. I replaced the Creality control board with a TH3D Easy board. That's a 32-bit control board running Marlin 2. I added an Easy ABL sensor. That's this sensor here. It's a capacitive auto bed leveling sensor. I had already put in a Micro Swiss hot end, not an extruder, but just the hot end. That's an all-metal hot end. We'll look at that in a moment. I use Capricorn tubing. That's unimportant now because this tube is no longer a Bowden tube. The filament's pulled through by the gears right here. We'll look at a close-up of that in a minute. So all this tube is doing is it's a guide so the filament doesn't flop around. But when it was a traditional Bowden extruder, that Capricorn tubing, which is more precise, made a difference. And probably the most important upgrade I made on this printer before changing to a direct extruder is I installed a CME CNC Easy extruder. That's an extruder for a Bowden style printer. I think it's the best Bowden style extruder available if it fits on your printer. Now, the Easy extruder I replaced with this direct extruder. The Capricorn tubing doesn't really matter anymore because of this wonderful Micro Swiss Direct Extruder. Now, why do I think it's a wonderful direct extruder? Let's look at some pictures. First, on the bottom right, you'll see that it uses dual gears. There are two sets of intermeshed gears, and it pulls the filament between those gears. Those gears have aggressive teeth on them that lock the two gears together and really well-calibrated teeth that pull the filament through the middle. The other thing I really like about this architecture is most direct extruders, and I'll show you some pictures here, look like boxes. They're fully enclosed. You can't see what's going on inside. That means if your filament jams, if something goes wrong, they're really hard to maintain and work on. Look at this Micro Swiss Direct Extruder. You see everything's out in the open. If that filament jams, it's going to be trivial to fix it. And that makes this an easier direct extruder to use and eliminates one of my complaints about direct extruders, that they're hard to maintain. Now, let's look overall at the difference between a Bowden and a direct extruder architecture. On the left, in this picture, we have a Bowden style extruder. The filament comes off the reel. There's a geared system mounted somewhere on the printer, generally on the frame. And you can see that right here in this particular printer. That extruder has a series of gears. It could be dual geared, it could be single gears, that pushes the filament through a tube. In this case, this white tube here is the Bowden tube, and that tube is flexible. So the filament's being pushed from here. It has to be pushed all the way to the hot end. Now, that means the precision that can be applied to extrusion will be dependent on a lot of things. One is how precisely this tube is manufactured. If there's more space between the tube and the filament's going to flop around a little bit. That's going to impact your extrusion. If there's not enough space, it's going to drag. That's going to impact your extrusion. That's why I use Capricorn tubing very often. Haven't upgraded this printer yet on my Bowden style printers because the tolerances are tighter. Now on the direct extruder side, you'll see that the filament is pulled off a reel. It goes to an extruder. We can see that right here. It goes to an extruder that's right on top of the hot end. That means that there's very little slop in the system. The advantages of that are better extruder consistency and the ability to use a wider range of filaments. Flexible filaments that flop around a lot are problematic in Bowden style systems. You can print them, and when this Ender 5 had the Easy Extruder on it, the CME CNC Easy Extruder, I used it a lot with flexible filaments. But in general, direct extruder implementations are better with flexible filaments. Now let's look at the other thing I upgraded, which I don't think is impacting speed, but is a nice upgrade. On the left-hand side, you'll see a Creality style hot end. The PTFE tubing, the Bowden tube, or the Capricorn Bowden tube in this case, is pushed all the way through to the nozzle. The advantage of that is there's nothing inside that nozzle for the filament to catch on. The disadvantage of that is PTFE tubing begins to release gases. They're not necessarily good for you at about, 230 degrees Celsius, maybe a little bit higher, depending on the tubing. Capricorn tubing can go a little higher than the regular white style tubing in most cases. In all metal hot ends, the tubing doesn't go into the hot end. It stops at the top of the hot end on the cool side of the hot end. The disadvantage is you have a little bit of a lip, in essence, between your tubing and the hot end. And depending on how the hot end is manufactured, there could be other seams in there. The advantage is you can run in your hot end safely at much, much higher temperatures. So this Ender 5 now has direct extrusion, an all-metal hot end, and in fact, instead of a brass nozzle, it has a hardened steel nozzle. So I can print abrasive materials that require high temperatures on this printer. Now, let's look at some results and see how this impacts performance. So here's a graph of the various print runs that I performed. You'll see the stock Ender 3 style printer printed this print in about 153 minutes. Now, my profiles can make a big difference. So what profiles did I use? I did all the slicing for these prints using Cura 4.11. Let me tell you something about Cura and Creality printers. When Cura released, I believe it was version 4.0, they included a whole new set of profiles for Creality printers with the slicer. Those profiles were crowdsourced. That means many people participated in the designs. There were lots of discussions. They're highly optimized. Prior to Cura version 4, most people for Creality printers used a custom profile they got from someone. For me at least, as of version 4, the profiles that ship with Cura are really good. And I might tune temperatures a little bit and retraction a little bit, depending on the filament brand I'm using. But in general, I use the stock profiles. So to make this test fair, I used the stock Ender 3 profile, and I used the stock Ender 5 profile. The only change I made was to add a G29 to each of the start codes so the auto bed leveling would run before the prints. Before I look at Cura print times, how do I know they're accurate? Well, because I did a test. I printed this on the original Ender 5 with the standard Bowden setup, and Cura estimated to take about 2 hours and 3 or 4 minutes to print. Actual print time was 2 hours and 1 minute. So I knew I could more or less trust the Cura times to get me in the right ballpark for these estimates. So the first print took 153 minutes. The fastest print took 93 minutes, which is a 40% improvement in speed. That's really a big deal. You'll see in this graph that going from the Ender 3 to the Ender 5 with an original Bowden setup, the speed improved pretty dramatically. What's that all about? Well, let's start by looking at that. On the right, you see the Cura profile for the Ender 5. On the left, you see the Cura profile for the Ender 3. The key factor here is the default speed. The default print speed for the Ender 3 is set at 50 millimeters per second. For the Ender 5, it's set at 80. Why? Once again, look at the physical construction. This thing is a box, and the print bed doesn't have to shake. It moves up slowly. So just by having a different architecture, even with a Bowden setup, you get good speed on the Ender 5. The disadvantage of the Ender 5 is when it's set up as a Bowden printer, the Bowden tube is much longer than on the Ender 3. That means you potentially need more retraction, which might offset your better print speed. But just by going from a more flexible frame and a print bed that moves back and forth to a rigid frame and a print bed that only moves up, we were able to increase speed. Now, moving to a direct extruder didn't make as much difference as I thought it would make. And let's look at why. You'll see that with this model, retraction takes about 13% of the print time. And going from 5 millimeters of retraction at 45 millimeters per second to 1.5 millimeters of retraction at 35 millimeters per second only shaved about 1% off the print time. So for this print, the advantage of direct extrusion for retraction doesn't really make a difference. Now let's look at a different print. I printed this as an example of a print that has an enormous amount of retraction. Now I'll tell you, the print quality of this print is just okay. And one of the problems with this print is I think the level of detail in this print, how fine these individual lines are, is pushing the boundaries of a 0.4 millimeter nozzle. So I think I need to either scale this print up or print it with a finer nozzle if I'm going to print it in this size. But it was a good test to look at times. Retraction on this print is 42%. Therefore, going from a Bowden style to a direct extruder makes much more difference because we went from 42% of the print time to 33% of the print time. Now, if we go back to our graph, we'll see that by increasing the print speed from 80 millimeters per second to 150 millimeters per second, I pretty dramatically reduced the print time. Well, the question is, when you do that, will quality suffer? Not a bit. Why is that, and what does that have to do with the direct extruder? Well, if we look at these pictures of this direct extruder, once again, the gearing is dual gears that are locked in a mesh, and it grips the filament very firmly. That gives us the ability to push the filament through at a much higher speed without slippage. When you have a single gear and an idler wheel, it's much easier for there to be slippage in the system. With dual gears, there's less slippage, and therefore I can drive the printer at a much higher speed and still get good quality. You'll note that when I went to the front panel of my Ender 5 and I cranked the speed up to 300%, it didn't really print any faster. What's going on there? I would have expected it to print much faster. Well, there's an overriding set of parameters that are in your firmware that gate your performance. And those are the acceleration and jerk parameters. Acceleration is very easy. How fast is your printer able to go from 0 to X speed? Now, we know it can't do it in a straight line. You have to start the stepper motor. You don't want to jerk it to a start. It'd be like flooring your car and pushing everyone to the back of your seats. Probably not a good thing for the car or for the passengers or for other people on the road. So you want to ease to your speed. The ability of your printer to get to the desired speed is called its acceleration. And in your firmware, you set the acceleration you're going to allow your printer to go at. If you attempt to go from 0 to 100, let's say, too quickly, you'll potentially damage your machine, your stepper motors, belts will slip, other things will not work well. Now, what is the jerk control in a 3D printer? Well, you're running at 100 miles per hour, you want to stop, don't want to slam on the brakes, you want to decelerate smoothly. So the jerk control controls deceleration. Now, if we look at the Cura profile that's included for the Ender 5, we'll see there's G code, it's called the start code, that's sent out at the beginning of every job. In that start code, they override the settings in the firmware. The first thing they do is they set a maximum acceleration. Then the next thing they do is they set a maximum absolute speed, the speed you can move from point A to point B, whether you're moving on the X, Y, or Z, or you're using it to extrude filament. Then they set other parameters for specific acceleration. And finally, they set jerk control. So these parameters, which I have not attempted to tune for this video, are why I'm really limited to whatever the top speed I saw when setting it at 150. Even if I crank up the front panel, it's going to be limited by these parameters. Now, the one parameter I'm most likely to try to adjust is the feed rate or the maximum speed for the extruder, because I'm sure this extruder can go a lot faster than a traditional Ender 5 Bowden style extruder. So let's summarize. What do you need to do to print faster? Well, you need a more rigid frame. The Ender 5 has a more rigid frame. You want to minimize bed movement. The Ender 5 bed goes up and down instead of back and forth. Direct extrusion will allow you to push your rates much higher because you can extrude filament much more quickly. Direct extrusion, by the way, will also help when using a larger nozzle size. What are the disadvantages of direct extrusion? Well, this is clearly heavier than just this independent extruder mounted over here, because this stepper motor that's right here is now mounted on top. In the case of the Ender 5, I'm not as worried about that because of the architecture. The architecture is such that there's a very rigid frame holding this X-axis in place. And I've seen, even at printing at very high speeds, I've seen no disadvantages of that. The other disadvantage of direct extrusion is when this is in a black box where you can't see it, they're harder to work on. But by using the Micro Swiss Direct Extrusion add-on for the Ender 5, I was able to get the best of both worlds. So I now have an Ender 5 that prints as fast as my Prusa with an all-metal hot end that can, in fact, handle all the same materials as my Prusa. So folks, thanks for watching. I hope you learned something. I learned a lot. I'm really impressed with the Micro Swiss style direct extruder. Please go to forum.makewithtech.com to discuss this videos and others. There are, 1,300 people over there now that discuss these videos as they're released. You can learn a lot both by watching the videos and going to the forum. Thanks a lot. Please subscribe, click on the bell, and most importantly, let's continue to learn things together.